What is up, designers? Today we are going to be going over how to do the pulley and belt calculations on our robots. So the reason we need to do this is unlike sprockets and chains, belts, there are only certain sizes of them, and we need to make sure that we have the right center distance between pulleys in order to make sure that the belt will be tight enough. So we're going to start out. I'm just going to make a little rectangle. Just going to dimension these to make them, oh my gosh. Okay. Now I'm going to make two circles, and I'm going to make them equal. And these circles are going to represent the center points for our two pulleys. I'm going to make them the standard size that we use for bearings, which is either 1.125 or 1.128. I'm doing 1.128 just for more tolerance. So now that I have that, I'm going to measure the center distance here, and it's this random number. So if this is our ideal center distance, the odds are we won't actually be able to use it if we're doing pulleys and belts. So we're going to see how we can get close enough using the West Coast Products belt calculator. So the first thing you see, it asks for the pitch. So there are two types of belts that we use. There's 3mm and 5mm. The 3mm ones are also called GT2, and 5mm is also called HTD. So most of the time we use 5mm. That's fine, you can use all that. So let's say both pulleys, we want them to be 24 teeth, and we got this center distance. So I'm going to put that in the desired center. It doesn't need to be super precise because odds are it won't be like that. So I let it calculate, and then it gives me three options. Usually you go with the desired belt, but sometimes it's beneficial to go with the shorter or longer one. So now I can copy that and change the length here to be this size. So now, like if I actually made a plate and put bearings in and put pulleys on it, we could use a 170 tooth belt, and it would fit perfectly. There's one more way to do this that we do. Let's delete this and say we wanted, let's make them both horizontal to the origin. Okay, so we're going to make this a plate. So we haven't gotten into Featurescripts yet, but we're going to get into them soon. And one of them is the belt and pulley generator. So the way this works is you can import the width is how thick it is. So generally it's either like 9 or 15. So I'm just going to say 9. And then you can say the teeth count for both pulleys. So back here we did two pulleys that were 24 teeth. So I'm going to do two pulleys that were 24 teeth again. And we have bearing holes here, meaning there's probably a hex shaft going through. So I'm going to go ahead and give it a 1/2-inch hex bore for both ones. And I'm going to give each a double flange as well. So let me just... Okay. Now it's going to ask for the origin. So those are just your 2 points. And then give it a second and it generates these pulleys. So you'll see the flange is this bit that sticks out on top. If I remove it, see, it's just like that. Okay. Now, how this has to do with the distance, because up here it says center distance is inaccurate, and then it gives you a recommended distance. So I can copy that and then go back into my original sketch, and I can use this to make it the proper length. Personally, I tend to use the West Coast Products belt calculator for 2 reasons. A, you can do it before you've actually made your pulleys, and if you're using COTS pulleys, then you don't have to generate them. And also, this it only gives you like one option for the closest one, and like I said, sometimes it's beneficial to have a shorter or longer one. Yeah, but those are two ways that we find the proper center distance for pulleys in order to make sure our belts work well.